There's something strange about building a fire pit here in the dead middle of summer. I mean, it's early August, and you know, if the thermometer's to be believed, it's 108 degrees here in Dallas. Fire pit is not the first thing on my mind, but fast forward 60 days and might be pretty handy. So we're heading over to my buddy's shop. He's got a plasma table, does architectural work. It's gonna save a lot of time, right? Rather than going and spending a whole day cutting this back all just by hand. Sure is easy when a computer does it for you. All right, so hey, this is just all basic 1/4-inch plate, right? No alloy, no Corten, nothing like that. Just inexpensive, mild steel, 1/4-inch, handles heat, welds easily, and cuts even quicker. So look, you do want 1/4-inch, maybe minimum 3/16 to kind of get this done so that when we weld it, it won't crack later, right? More material is more ability to soak up heat. One of the really cool things about running a plasma table, anything like that, is that it is fast. But you know, the cut does need to be cleaned up, right? This is not laser nitrogen where you can weld straight to it. So best practice is to always just come back with the grinder. I've got mine, my big 6-inch setup with a flap wheel, and I'm just gonna put in some headphones and I'm just gonna clean up all these joints. They don't have to be perfect, but it's too easy an opportunity to get basic slag and everything off. One of these plates is a little rustier than the other, so I'm just gonna hit it with a surface conditioning tool. It's pretty doggone good for taking off rust. There's just one piece that's rustier than the others, and it's kind of like, you can make it look nice, so why not? So this is like a modern style fire pit, right? All plate design is gonna piece together. The bottom two are, you know, tab and slot, and they're gonna piece together, and then the rest of this kind of stacks inside, and we're gonna tack it as we go. All you wanna make sure is, at these early stages, this is the first thing that we're gonna tack, right? So if it's got right angles, just triple check that they're, you know, use what you have, whether it's a speed square or a 1, 2, 3 block, something along those lines, but you're setting a foundation right now. And it's not permanent, right? We're gonna put a tack here, and then we're gonna be able to flex a little bit later, but you know, it always makes sense to just try and get it as tight as you can. This is a very nice multi-process machine, the Multimatic 220. I use TIG a lot, and that's actually just kind of how it's set up right now. I also like to tack with TIG, regardless of whatever process I'm using, because you can run over TIG tacks with TIG or with MIG, but a MIG tack, by its nature, tends to be a little cold, and especially early here in the process where we're fitting stuff, I don't want a cold tack. I want something that's good and hot and gonna hold it all together. So that's also my personal preference. I don't know. I think TIG is elegant.
Warning: read and follow all labels and the owner's manual.
Okay, so we used just some quick clamps, and then I had like pieces of square tube laying around the shop. But any old thing to give yourself something to hold and brace this next panel, so that I don't use my buddy, a Chris clamp. We'll just use a vice grip. Man, I think that's gonna work. What I think I'm gonna do is I'm gonna give a real small tack here at the bottom just to hold it. Looks like that's gonna fit about the same. Seems pretty close.
I think you can go in a circle.
Yeah, all right, that's what I'm gonna do. Chris, let's put on the grate and let's see what that looks like. Rotate and keep going. You know, the thing about this is, like, a project like this is you do need a welder, but you don't need a bunch of tools. You need some clamps, you need some leftover square tube. Mostly you just need patience, right? I don't want to weld these last two bottoms until we set the bottom in there. I'm glad we left a little bit of slack in this. I think I'll throw tacks here down here in the center and then put some on the outer edge. And then this thing's ready to preheat for MIG welding. So it's kind of ridiculous to do all of that with the TIG, but I just really like that because you can make small tacks and they're easy to break and adjust later. Not something that we had to do, but that was at least my thinking as to why I spent all that time on the TIG settings. But it's a multi-process welder, the Multimatic 220, and we're gonna MIG the rest of this because that's far more efficient. But I need to change the wire size. I've got 24 wire in there right now because it's just what I had, but I got a new spool of 30 wire, and yeah, we're gonna switch it over and get to work. So I'm just shutting off the argon and opening up the C20. The machine automatically knows when to switch over. It's pretty straightforward. We're on 30 wire, and 1/8 inch. This is 1/4. Let's just start there. Sometimes I pull wire speed out of it. Sometimes the settings are pretty rich on wire, but I usually just leave it alone. Kind of trust what the machine says. I want to make sure that I've got a little bit of heat in this. It is 1/4 inch. And I don't need to heat the whole thing, but I do need to heat where I'm gonna start so that I can get good penetration. The machine can compensate for a lot. It'll start hot and then it'll taper, but it's just a whole lot easier if you just give it a little bit to start with. Do take the time to wear your respirator because this thing makes a ton of fumes, just normal CO2 welding. Instead of just like, some people will drag and there's a bunch of wiggly techniques. I'm just doing a very basic, if we pretend this is the joint right here, weld and drag down and then come up and then drag down and then come up and drag down. Really straightforward. And it gives a little bit of that bead profile. Okay, we're fully welded here on the backside, and it is important. My friend who designed this, they built several of these fire pits, and he gave me some coaching that just basically is weld every seam, right? Don't stitch weld it, meaning leaving gaps in between some welds, right? If it's gonna handle heat cycles, expanding and contracting, as you run several fires in here, their experience says that the whole stinking thing needs to be welded every seam all the way through. So with that in mind, I actually cranked up a little bit more voltage on the 1/4 inch settings. So I'm running 21.5 volts and 456 on the wire speed. So it is hot. I mean, that you get a nice, deep, good penetrating weld through this 1/4 inch. And all we gotta do now really is flip it over. A little piece of detail, you saw that I left most of the mill scale on there. I mean, it's clean, but it's not ground down to bright metal. I'm running -6 wire, so there's a little bit more silicon in it to be able to pull out, some of those impurities. And that's usually pretty good. I don't get all twisted up about making sure this is all perfectly clean, because they're not structural welds, right? It's just a fire pit. One of the things that I'm gonna do before all this stuff gets heat soaked again from welding is I'm gonna step down to 1/8 inch on the machine, and I'm gonna form and fill in these holes, right? That we set this up to where it doesn't come up to a point, but I'm gonna be able to fill in and get these with weld material in them. And I'll come back and I'll dress those down so it's a nice sharp corner. And I'll do all that with the grinder later, but I wanna be able to put the metal in there for now, and stepping the machine down, make sure that I'm not making a deep penetrating weld, and doing it while the material is still cold means I can get good build on it. It's just one of the artsy things, I guess, in the machine. So let's step down 1/4, 3/16, 1/8. Okay, I got the welder back up on, big boy settings, so it's 1/4 inch, 21.5 volts. That's the only thing I changed is the voltage to make it a little hotter. We've got some fill, which is by design, right? This is supposed to have a gap. So I'll probably modify my weave to start in the center and then work to the side, start in the center and work to the side, be able to get the fill. And then we're gonna do this, we're gonna do this downhill because it's a lot easier that way.
While this is hot, I'm gonna go ahead and get these two corners right here just because everything's sort of preheated.
I took one quick little break because something I realized while I was welding was to explain exactly how I manage multiple torch positions, because these are long welds, right? So you gotta kind of make a plan. I weld this in 3 segments, and what I do is I'll get my hand, kind of generally placed, and then I'll just run a distance about like that that'll feel normal, and then I'll place this hand as a rest, and I'll try to be like 50% uncomfortable at the start and 50% uncomfortable at the end, so that there's like let's say a fat middle, 75% of the travel to where my hand is really very comfortable, the torch position. And you can usually get like 6 inches. For seams like this that are 18 inches long, breaking them up into 3 is pretty easy.
That's the last weld.
Oh man, that is it. What a good day. What a good Saturday. Like, we cut this on a Friday night over my buddy's shop, brought everything back, cleaned it up. We didn't start too early. on a Saturday, and here we are. It's not even 5 o'clock. It's almost cold drink time. Anyway, thank you, Miller. Appreciate you guys giving us the challenge to build something in a day. Look, thank y'all for watching. And until next time, take care, okay?